Hi, my name is Leandro Facchinetti and let's write some code together, shall we? What we have on the menu today is part 9 of this series of streams in which I am working on an open source project of mine called Caxa. The purpose of Caxa is to package Node.js applications into a single executable binary, which is beneficial if you want to deploy that Node.js application to some servers. Very simple deploys without Docker or anything. And also if you have a command line tool developed with Node.js and you want to distribute that. Those are the main use cases that I know of for Caxa. In any case, it's this Node.js application that allows you to package your Node.js projects. So last week and in most of this week, what I was working on was ARM support. So I was adding support for the ARM architecture, particularly on Linux. And that's useful for people who want to run Node.js projects using Raspberry Pis, for instance. And since Wednesday, the last time I worked on this, I was looking at my to-do file, and there was this thing that we worked on last week with the help of Matt, who developed a whole workflow to compile stubs for... So Caxa depends on these stubs. Wow, I'm getting very bright. Okay, that's better. That's too dark. Okay. So this seems good. So yeah, Matt was helping me with the compilation of these stubs because Caxa depends on these stubs, which is a simple Go program that extracts your Node.js project that is packed as a tarball into a temporary directory and then runs your project from there. And there is this small Go program that I need to compile to bootstrap the process of executing a binary. And we now compile this Go program to all the different architectures that we support, like Linux, macOS, and Windows, Linux ARM, macOS ARM. We compile this Go program to all these different platforms, and we are using GitHub Actions to do this. And Matt was he wrote most of the configuration for GitHub Actions, and he was using this GitHub action called setup QEMU action. And this is how we are using setup QEMU action. So I went looking for the documentation for this action because I'm interested in offloading some of the configuration that we wrote here. I would like that to be part of setup QEMU action. That would be ideal. Then I wouldn't have to maintain this part. So we have this to do here to go to this project and suggest this change. But then I didn't really suggest the change, not yet. But I looked at the docs in two places. One over here in the README, and also this is not really documentation, it's really the specification that actually runs in the GitHub Actions. So in both places it seems like the platforms defaults to all. The platforms defaults to all, it's not required. So when we say platforms all, that's redundant. And I believe it's safe to remove these lines. And I always like removing lines and using the defaults instead, convention over configuration, right? That's the ethos of the Rails community, which I have been a part of for, well, like 5 years, but that was like 8 years ago. In any case, convention over configuration, I think that's a good ethos. So I'm removing these lines. The interesting thing is, I don't know really why Matt wrote this way, but it seems like in the documentation, the example has both image and platforms, and both image and platforms are not required, and we are using the default in both places, so I don't know why he included the platforms here, but I don't think that's necessary. In any case, that's a small change. I wanted to get that out of the way. Now let's go to the main course, which is the second part, the other half of ARM support. So on the first half, we had to compile these stubs the right way. and we did that. The second half is to use these stubs the right way in the JavaScript portion of the project, and we worked on that most of this week. And each day I finished saying, okay, this is probably going to work. Well, this is probably not going to work, but I wish it worked. And then I push something, and then I end the stream. And then it always fails. So now we are going to look at what failed last time, which was Wednesday, and we are going to figure out what went wrong and try to fix whatever was wrong. So it seems like most of the steps are working, and I will go over them briefly. So this is compiling for Linux ARM. It's using Docker to emulate an ARM architecture. Hi, Larry. It's good to have you here. Yeah, so this uses Docker to emulate ARM and then runs the Go compiler and produces these stubs, which kicks off the process of running the binary. Then this does not rely on Docker, it just builds for Intel 64, and this was the only architecture supported up to when we started working on this. And there is also Darwin ARM. This one is not super essential because support for ARM in Node.js is new. It's only in version 16, which has been released 1.5 months ago. Also in macOS, we have Rosetta 2, which allows you to run Intel binaries in macOS ARM. So in the M1 processors, you can run Intel programs. So having a stub for ARM on macOS is not as essential as it is in Linux, because in Linux, in a Raspberry Pi, there is no emulation in place. You cannot run an Intel binary in a Raspberry Pi. So all these three build steps are working. Excellent. Let's hope that they continue to work after my small change on the configuration to remove that line that supposedly is unnecessary. So I removed a couple lines here. So that is all for the build. And then the checksums is just taking all the binaries that were produced and collecting them and producing a checksums file that allows you to check that whatever stub you end up using is the stub that was generated during this GitHub Actions run. So if you trust Microsoft to run the GitHub Actions cleanly, then you trust the binaries that came out. And then there is the test on Intel. So the tests here are really running all the tests that we have in caxa, which package, these tests are packaging some example applications. They are relatively small, but they have complicated features to compile into a binary, like native modules in Node.js. So you can think of modules like Sharp, which does image manipulation, and SQLite, which is a database that is embedded in your application. So all those packages require native extensions that are written in C or C++, and they are difficult to package using other packages like PKG by Vercel and Nexi. They don't handle native modules all that well, while caxa does that very naturally. So all these tests passing is great news because they used to pass before we started this, but then the tests on Linux ARM are not passing, and we need to look into that. And just by how long it took for the tests to fail, around 5 minutes, I have an educated guess of what went wrong. We talked about this in a previous stream, that running all the tests in ARM is probably going to be very slow because some of the dependencies that we are using on the tests, like SQLite, they are slow to compile in ARM, and there are no pre-built binaries for those architectures as far as I can tell. So I have a timeout here of 300,000 milliseconds, which is 5 minutes. And that timeout is good enough for Intel because in the Intel tests, you are fetching pre-compiled binaries of SQLite and Sharp and so forth. But in ARM, you have to compile those from scratch, which takes a lot of time. So probably that's why the tests are failing. But let's look at the failure and see what is going on here. So first of all, we are running on ARM, so we need Docker to emulate the architecture. So what you're seeing here is Docker spinning up the image that emulates ARM. And this image happens to have Node in there already. So yeah, that's cool. We have ARM emulated using Docker, and we have Node already installed in the image, so we are ready to just say npm install and try run the tests. So the post install script is a no-op in this particular case because we already have the stub which was compiled in the previous step. We're just putting the stub in the right place, so the post install looks at the directory structure and sees, oh, there is already a stub there, so I don't need to do any work. And that's a script that when you install from npm, it will go fetch the stub from GitHub Actions. That's work that we did on Monday and Tuesday. And Felipe says hi. Hi, Felipe. It's good to have you here. And then after the post install script, we run the tsc command that compiles TypeScript into JavaScript, which is necessary for distribution of the npm package, but it's not really necessary in the tests. It still runs. And then there is the actual test. So first of all, it checks that the format is followed, that we are using prettier to format the files and that the files are formatted with prettier. That's fine. And then jest. So the formatting is all good. The problem really is in the test. And this test that is like our hello world test, it's a smoke test, it passes. And just by having that passed, I am pretty sure that we are okay. If we only run this test in ARM, I'm already happy. And this test is taking, 41,000 milliseconds, which is almost 1 minute. So we are giving a timeout of 5 minutes, and this takes almost a minute, which is already very slow. For a hello world situation, it's very slow. And then the false, it's kind of another hello world. What this one tests is, so this is a hello world that tests all the command line parameters that you may pass to your program. And this test tests the output status of your program. So when you run a program, after completing, it will return a status which represents success, the number 0, or any other number represents failure, and you could have multiple failure modes. And this program returns failure just so that we are able to see that, okay, the failure that your Node.js program produced is forwarded by the stub. In the Go program, you forward that status code up the execution chain. So that's a very simple test as well, and it takes about the same time. And then the native modules fail. But that's kind of expected because of the timeout reason, but it seems like there is some other problem here as well. So when it's trying to run npm install, it says permission denied, and then it gives me the logs directory, which makes absolutely no sense. But it says your cache folder contains root-owned files due to a bug in previous versions of npm, blah, 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 blah. And it says to permanently fix this problem, run that. Okay, we could run that. Okay, maybe Felipe has the answer here. He says, the problem is with running npm install inside a different directory than the working directory. You can do that. You can do what npm recommends, or run npm install force, which will skip the cache, or set npm config cache to point to a different location that doesn't mess with root. Okay, thank you. I didn't know all this. So yeah, that's helpful. I am not inclined to do this, however, because even if we don't have the permission errors, first of all, let's talk about the nature of the problem here. We are talking about a problem that has been fixed already in npm. So we can expect that in the near future, oh, that's interesting. Felipe is saying that this only happens with Docker. Okay, so first of all, this seems to be a problem that in the future will solve itself without our intervention. But even if we do some of the workarounds suggested by Felipe, so even if we do something like this, for instance, I think that then we will run into the timing problem. And really, we are doing the ARM support here. We are testing that the stub is working just by having this test pass. The stub is definitely working. And I think that the test would take too long to run, which can be a problem because of the timeout, but I can always bump up the timeout. The real problem here is we would have to wait a long time to release anything on on NPM, and these tests are low priority. We already know that the stubs are working because of this test, and we know that the whole thing is working because of other tests on Intel. So we are already running on versions of Node of 14, 15, 16. I think I'm happy with just letting these tests not run in the ARM architecture. So that's what we are going to do, because it simplifies the problem, and we already have a precedent, really. Some tests only make sense in some platforms because of the packaging that happens. This is a specific way of packaging for macOS. So we already have a precedent. So what I'm going to do is, let's look at all our tests. So we have here, I guess 4 tests total. So we have the hello world, and I would say that this is probably a priority. We want to run this in ARM. And this is macOS only, so no complaints there. And this is kind of a hello world, as I explained before. So I guess the only thing we have left to do is say if process arch is different from, or actually if process arch is equal to x64. This way we are only running tests on Intel. And maybe we could look at the platform in Linux as well. So if we are running this on a new Mac with the M1 processor, then these tests would run. But that's not an issue in our GitHub Actions situation, because we don't even have infrastructure to compile or run tests in M1 processors. As far as I can tell, you cannot emulate that, and there is no native support in GitHub Actions. There is no GitHub Actions runner for Macs with M1, so we are not running the tests in that architecture at all. At some point, I'll probably run the tests on my streaming computer, which is a new Mac with the M1 processor, but that's low priority. So I think that this simple naive line here, I actually have it wrong. So if the platform is equal to Linux and the architecture is Intel, so that line is wrong. But once I fix this line, I think it will fix our issue. So let's go over the line again. So if the platform is Linux, or maybe different from Linux. No, what I actually want to do is, if the platform is Linux and the architecture is ARM, or the architecture is ARM64, so either ARM or ARM64 includes the process architecture. So this time we are saying, if the platform is Linux and we are on ARM, then I should not run these tests. So if it's not the case that the platform is Linux and the architectures are these ones, then this test will run. This reads very wrong. I will use some, what is it called? De Morgan law? Yeah, De Morgan laws. I will use the De Morgan law and try to make this read slightly better. So the De Morgan law says that you can replace the not and push it into the conditions and change the and with an or, and that amounts to the same. So if my platform is not Linux, so I am in macOS or Windows, or my platform is not ARM, then I run the tests. I'm having a hard time to get my head straight here, but I think that's the situation. So if I am in macOS or Windows, always run the tests. and if my architecture is Intel, so it's not ARM, or, oh, so I guess another way of saying this is coming back to process arch is equal to x64. Yeah, so if I am not on Linux, or if my architecture is Intel 64, then run the tests. Okay, that was a long way of getting to this line. Maybe I'm tired. So let's run the tests on my machine real quick, because it should include the test for native modules. We should see native modules as part of our output. But I'm pretty confident that I got the line right, so I'm going to commit, and I will come back here to the terminal, and I will say npm version pre-distribute and pre-id equals beta. Okay, invalid version, it's not pre-distribute. I think I have that on my, oh, I have that in my history of commands. So yeah, it's pre-release, and that creates a new release. So let's push this guy, and we'll see what happens in GitHub Actions. And I'm parallelizing this because GitHub Actions takes its time to run, and I want to run these tests as quickly as possible. So the tests will be picked up in GitHub Actions, or have been picked up already. Yes, the tests are going to run now. Of course, it's going to run the whole thing, compilation and tests on Intel and everything. But build on Linux is fast. It's already over. That's fun. And then, yeah, my tests include native modules, so I got my line right. Yeah, if I'm not on Linux, or if my architecture is Intel. So if I am on Linux, Intel, this will run. Okay. So with that, I think that this will pass. But while we wait, let's go over the next item on the list, which is to make extraction atomic. So that's a whole different story. We are now switching gears from Node.js into Go. And the story here has to do with how unpacking or decompressing your project works. So as I said, caxa is this simple Go stub that contains, so we concatenate your project with the stub. So the stub looks at itself as a file and finds your package, it's a tarball, and unpacks the tarball into a temporary directory. And then it runs your project from there. Now the problem here is, what happens if you are in the middle of extraction? Maybe you have a big project and extraction takes a couple seconds and something goes wrong. One thing that went wrong in my case, and that's how I discovered the problem, was that I had a relatively big project, and while it was unpacking, I thought, this is taking too long, maybe something is wrong, and I hit Command C, or no, not Command C, Control C, which stopped the execution. So it stopped the decompression in the middle, and I ended up with this inconsistent state. The directory was not fully unpacked. Now, the thing to understand about caxa is that it tries to be as fast as possible, so the next time you run, it will not try to decompress the project again. It will only see, oh, there is already a directory here, so I will just go ahead and use that. The problem is, the directory was not fully extracted in the previous run, and then you end up with this inconsistent state, and the only way to get out of it is to learn how caxa works, understand that there is a temporary directory that is in an inconsistent state, and go delete it. So for me, that was okay. I developed caxa. I knew the problem the moment I saw it. But it is unfortunate. So we have essentially a race condition here. Because the same exact problem could happen if you run your project twice at the same time. Then the extraction would try to happen in the same directory at the same time. That can never be good. I mean, at least extraction is idempotent, so it doesn't matter how many times you try to extract. If you try to extract, you will end up with the same directory with the same contents, but extraction is idempotent, but it's running caxa itself is not idempotent, because caxa will look at the directory and see, oh, it's already there, so we'll use this cached version. I call it a cache, so we'll use this cache version instead. So that is the problem here. The solution, I think, is to have a lock file. So here's how this is going to work. We are going to start the execution by looking at the directory. Does the directory exist? If so, I will look for a file that will have a specific name that we will make up, and this name will always be the same. If the file exists, okay, I'll start writing this down because it's a series of steps that I have in my head. So step number 1, look at cache directory, which is our temporary directory in which we extract our project. So 1.1. The directory doesn't exist. Okay, so that's the first run. The directory doesn't exist. And then we'll also have 1.2. The directory exists. Okay, if the directory does not exist, then create the lock file. This file is not special in any way. It's just a file that will have a particular name, and it acts as a flag. Because the last thing we are going to do, I don't know the exact number of this step, but it's the last. We will remove the lock file. So we are releasing the lock. Okay. Right now, we create the lock file and we start extracting. So we start extraction. And I guess the last step is number 3. So we are going to create a lock file, start extraction, and once extraction is over, when extraction is over, remove the lock file. So we are using a file as a lock system for the critical section of our program, which is the extraction. Here I'm throwing all these terms around, and they are terms that you typically see when people start talking about concurrency and concurrent programs. The idea of locks and releasing locks and acquiring locks and critical sections of programs and so forth. Okay, so that's what we need to do if the directory does not exist. So we create this log file. But how do we use the log file? Well, we use the log file when the directory exists. So step 1.2.1 is, or better yet, the directory exists is not very clear. So look at the cache directory. So the cache directory doesn't exist and the cache directory exists. Okay, so if the cache directory exists, look for the lock file. And then we have 2 possible outcomes. The lock file doesn't exist, or the lock file exists. If the log file does not exist, it means that extraction was over. So that's a lot of sub-steps. But if the log file does not exist, it means that our extraction was successful. So go ahead and use the lock, the cache directory. If the log file does exist, then it means that either we are right in the middle of extraction by some other execution of the program, or the program ran but failed to complete the extraction, and now the directory is in this inconsistent state. But I cannot tell which version is it, because I cannot really query, is this program running in another process while I'm trying to, no, that I think in theory would be feasible because there is such a thing as inter-process communication, but I don't want to get there. I think it's just too complicated. This is already an edge case. It's hard to get into this edge case. So what I'm going to do instead is, if the log file exists, then, so I'll put here a comment saying extraction or previous extraction was successful, so go ahead and use the cache directory. And in the other case, previous extraction was not successful, so pick another name for the cache directory and go back to step 1. So what we are saying here is the previous extraction was not successful, or is in the middle of happening, so, or is happening right now and hasn't finished yet. In either case, pick another name for the cache directory and go back to step 1. So I'm thinking about cache directories being named like 001, 002, and so forth. So you could have multiple failed extractions, or you could have multiple instances of your program running at the same time. It doesn't really matter. It will look at all the possibilities, and only when it gets to one that maybe the cache directory does not exist, it will start trying to create the log file and so forth. Whatever happens, by the end of this whole series of steps, I am guaranteed to have a directory in a consistent state. And I'm also reusing the directories as much as I can. So as long as one extraction is successful, all the executions that happen later will use this cache. So this is a long-winded way of doing this, but concurrent programming is always complicated, and I am not too experienced doing that. So I think it's nice to work out this theory of what should happen. And I think we nailed this. I think that this is pretty solid. Okay. Let's look at this. So the cache directory exists. So yeah, if the cache directory exists, we are either going to use it or we are going to go to the next one. Yeah, okay, that's correct. Okay, so that's the algorithm we will want to solve this problem. Meanwhile, let's look at this execution, and it was freaking successful. After weeks of working on this run is successful. In fact, we should go to npm caxa, and we should see a pre-release version there. Version 2.0.0 beta 5. Awesome. Okay. We are doing concurrent programming here because we are working on concurrent programming problems, but also because we are working on these two things separately. ARM support and the lock problem. They are separate problems, and I'm working on them at the same time. But okay, so we have this version. Now I want to try this version. So here's what I'm gonna do. I have some example projects that you can use caxa with. For instance, a web application. So let's go to this web application, and here's what we are going to do. I will open the examples folder, and I'll also open TMP, my temporary folder on my machine. So I have a web application that I think that this web application does use some native modules. So let's look at the package.json real quick. Yes. So SQLite is a native module. So we can copy this web application over to a temporary directory, and let's open Visual Studio Code in the temporary directory web application. So now we are not caxa developers anymore. We are just trying to use caxa to package our lovely Node.js application. And this application is relatively straightforward to package. It has not been prepared for packaging, but we can do that very easily by saying npm install caxa, and this is a development dependency. Now, I'm doing this without any specifiers for version because I want to make sure that it will download version 1. It will not download version 2 beta. It should not download version 2 beta. Let's see what it does. We have version 2 beta here just because we have to test the whole arc of this story, the whole let's go to npm and publish and make sure that this checksums file is in there and that we can download from GitHub releases and whatnot. So all these things need to happen, and they only happen when we actually publish the package. And that's why we needed to have this version, but this beta is kind of misleading. It's more like a test thing. So if we get this to work, I think I will announce this on the caxa issue for ARM support, and maybe someone will test this over the weekend and they can say if they run into issues before we do a honest to goodness 2.0 release. And this is taking a while to run, but it's probably because of installing SQLite, I think. So caxa is version star. I don't like that. Which version of caxa did it download? Star? Oh, we downloaded the beta. I don't like that. That's unfortunate. So between now and when we actually release caxa 2.0, people probably will run into problems. I don't know how to fix that. I don't know why npm decided to install that. Whatever, that's unfortunate. But in any case, now we have the version of caxa that we need. So the first thing is, in the node modules under caxa, there should be a stub file. And there it is. The stub file is there. This stub has been downloaded from the GitHub action, the GitHub release that was created. So here we have caxa, and we have one release. Where is it? There should be a release here. What's going on? Yeah, I couldn't find the interface for the release. It should be here on the right, but it isn't. Do I need to like refresh the page or something? No. I don't know where the releases should be, but I do know the URL for them. It's the project/releases. So here is our beta release, and here are the stubs, and this is where the stub was downloaded from. Let's file node modules caxa stub and see that it really is a macOS executable for Intel. So we downloaded the right version. Awesome. So with that, we should be able to npx caxa help, which will give us a line that we can borrow from. So we want the input to be our current directory. We want the output to be, I don't know if I can put the output in the directory that I'm packaging. I think I can. So I should probably be able to just say, awesome. This will be the name of the executable. And then we need to say what command we want to run when we run the executable. We want to run Node.js, so caxa is the placeholder for the temporary directory in which your project will be extracted. And then we want to do node modules .bin node. So when we package your application, we also embed the node executable that was used to run caxa. We put that in your binary so that your users never have to install node themselves. And then, how do I run this project? I believe I just, I think I will need to compile this TypeScript real quick. But once we have that, it will probably compile into a lib directory. So we probably just want to say lib because the file is already named index. So I think that this will work. But before we are able to run this command, we need to npx tsc, which will prepare the project for distribution, and this is something that you have to do in your build process before you call caxa. And here we have lib. So I suppose that just by saying node lib, it will run the server. So the server started on port 5000. Here is our example application. So now we run the command that we had before, and this will take a moment or two to finish, and meanwhile I will adjust my brightness because the sun is setting in front of me and the brightness is all over the place. Yeah, this looks nice. So why does this take a while? Well, because it is copying a bunch of files over, it is creating a tarball, it's copying things all over the place, but it's done. So here we have an awesome file, and when we run awesome, it should extract the application and run the server, and it ran the server, and here is our server from the awesome file. Awesome, now I am too dark. I could use auto brightness, but I don't like it because then the brightness is jumping in even if I don't want it to jump. Okay, so caxa is working. It has support for ARM, supposedly. Yeah, so let's continue working on this extraction thing. Oh, by the way, I think that we can come here to the issues. I really want to do this. ARM support is ready for testing. Please grab caxa at blah. Proper 2.0.0. We'll wait until I fix a couple more bugs. ARM support is ready for testing. Please grab blah blah and give it a try. The proper 2.0.0 will wait until I fix a couple more bugs. It will probably be out by the end of next week. Let me know how it goes. And the reason why I wanted to write this comment is so that I can press this freaking button that I wanted to press since March. Close the issue. We have ARM support. So proud. And proud of Matt too. A big part of this was his work to make all of this possible. Okay. Exciting stuff. Now let's work on the atomic extraction. I don't know of a way to write a test for this, because I would have to stop the execution in the middle, or I would have to... Oh, what's going on with the brightness? Or I would have to spin up multiple versions of the app at the same time. That is really difficult to test. And maybe I could put some like a fake failure. Oh, brightness is all over the place. I could put a fake failure thing on my tests so that in my Go program I could pass a special flag that would fail in the middle just for testing, but no, I don't want to do that. That's too much work. So I guess what we're going to do is just write the code for all this, and if the success case works, then maybe we will try by hand a failure case. I can run the extraction and stop it in the middle by hand, and if that works, then we'll call it a day, because testing this with automated tests is complicated. Yep, so that's how we are going to test this. The test strategy for this is manual testing. We'll do it once in a while. But let's start writing code for this. And the fun part of this exercise is that this code has to be written in Go, because the stub, which unpacks your project, is responsible for doing all these checks and whatnot. And I am no Go programmer. The reason why I wanted to develop Caxa was so that I could develop my apps in Node.js. I don't know my way around Go, so this will be fun. And I don't remember much of this program too, so this will be fun. Let's look at how this program works. Luckily, it's a small program. It's less than 100 lines of code, except for the part that actually does the tarball extraction, which I copy and pasted and adapted from other places. But we don't need to change the extraction itself. We only need to change the conditions under the extraction occurs. So that will be relatively easier compared to what could be the problem. So, okay, let's go over how this small Go program works. It starts by looking at itself. So it finds itself, the executable itself, because it will need to read itself as a file. So it looks at itself. When I ran the awesome program just a minute ago, the OS executable would give me the full path to the awesome executable. Then I read a file, which is myself. I read myself as a binary file. And then I get the executable. Now, how do I know where to extract? Where is this temporary directory that I need to extract to? I could create a random directory, but then I would lose the nice property of when caxa, your binary, runs successfully, the next run will be cached. So that's a nice property, I think. Especially if you have something like a command line tool. Your first run may be slow, but then subsequent runs need to be fast. So how do I know where to extract to? I cannot generate a random string because a random string would be different every time. What I do instead is I have this path that is always the same. And how do I know what path this is? Well, I have, as I said in my binary produced by caxa, I have this stub, and then I have a tarball of your project, but I also have something else. I have this footer that is some JSON in which I store some information I need. One of these pieces of information is the identifier, that is where I'm going to extract your project to. So where is this temporary directory? I also need to remember what command you need to run after extracting. So in my example where I was packaging the application, I had that node lib. I was running index in the lib folder. For that to work, the stub had to know eventually what node command to run. So I stored that in the footer as well. We have here in the README some ASCII diagram of what your binary looks like. It starts with the Go program, which is the stub. Then there is this separator called caxa, caxa, caxa. It's just literally caxa, 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 the string caxa, caxa, caxa in the binary. Then there is an archive. The archive is your tarball of your project. And then there is a footer. The footer is some JSON. And the reason why I have it laid out like this is because if you have something else that is not even a Go project and you want to use this stub as a self-extracting executable, you can. You just append your tarball to the file and then you append the JSON. And I have the JSON as the last part specifically because I can go from bottom up when I have just read the program, the executable. It's right here. This is the binary. It's a array byte, I think, or how is it called? A slice byte? It's a bunch of bytes that is literally the executable, and I can look at it from the bottom up and I will find my footer. My footer will tell me where I need to extract this to, what is my temporary directory. And then I can look there to see if I have the cache or not. And if I have the cache, I just go ahead and execute. I don't need to extract the archive again, so I don't even look at this portion of the binary. And that's why I have the footer last, because I can go from bottom up. If I try to go from top down, then I would have to read the whole thing. How would I know where the JSON is? I would have to read the whole thing from top down. So if the footer was, if this JSON information was, for instance, here, Then I would need to look for caxa, and then I would find the footer. I guess that wouldn't be a big deal. It would just reverse the order, but then I would have to do some slicing between caxa, and the end of the footer, or the end of the JSON information. So I find it pleasing to have this going from the bottom up just gets you a footer. Also, when you tail, so we can do that real quick. We can tail TMP web application awesome. And at the end of the program, there's a bunch of binary things here that are printed out very weirdly, but at the end, you can see the JSON. That is our identifier. This is where I'm going to extract your application to, and this is the command that you need to run. And that's what we specified when we built. We called caxa, so we called npx caxa. It's not in my history for some reason, but we called caxa and we passed these as arguments. Okay, so the identifier and the command are in this footer, and the footer is a footer and not something else for the reason I explained, so they can go from bottom up. And specifically in Go, I can use this last index to go from bottom up and find my footer. So now I have the footer index, and I look at the footer string just by looking at the executable and going to the index and then the length of the separator, which is just a new line. So I start at that position, and then I slice my executable, and then I get my footer string. Then I get parts of the footer that I care about, the identifier and the command. And then I just parse the JSON to get a hold of this information. And now we are starting to approach the part where we will make changes. I'm trying not to tweak the brightness, but the brightness is really bad now. Okay. So this is the app directory. This is the temporary directory where we will extract your application. It is in your temporary directory. It's under caxa/runs. And then it looks at your identifier. And we had an example of identifier. So it's called awesome, and then some random string. Cool. This identifier and command were produced, this whole JSON was produced by the JavaScript portion of the application when we were packaging the awesome application. So now we are looking at thus the app directory exists. That's our first step. So our cache directory, I should rename that to app directory. And then it becomes redundant to say app directory. Look at app directory. So that's our first step. We are looking at app directory. Does it exist? Well, to do that in Go, we have to do a lot of handstanding. First, we have to try to get some information about the directory. If the directory cannot be checked, then I fail catastrophically. If the app directory is a file and not a directory, I fail catastrophically. If the directory is a directory, I don't do anything. The directory exists. Use it as a cached version of the application and don't extract again. I guess we'll have to change something about this line. But if everything else here didn't match, it means that the directory does not exist. So then we are extracting the tarball. We are doing the tarball extraction here. So I will start putting some markers so we remember what's going on. Let's put our to-do file with the list of things that need to happen here on the right for reference. And let's go over what's happening. So look at app directory. That's our step right here. Step 1. The app directory does not exist. This is our step 1.1. and then we will do a bunch of things. What happens when the app directory exists? That's our step 1.2. And then we'll need to do a bunch of things. So let's look at what we want to do here first, because I think that's easier. There are fewer steps here. So what we need to do is create a log file, and then when extraction is over, remove the log file. Here we are in step 1.1. So before we start the extraction, so this part of the code, we'll do the extraction. Before we start the extraction, so I guess I'll put a note here as well. So the extraction is part 1.1.2, right? Following our reference here. So we want to do 1.1.1, which is to create a log file. And later, when the thing is done, we want to do 1.1.3, which is to remove the log file. And I'll leave here to-dos saying that this is what we need to do. Oh, I have the to-do in the wrong place. We need to do 1.1.1 to create a log file. How do you create a file in Go? We have that for sure in the middle of the untar, but I wonder if I can just Google for golang create file. Or maybe even golang log file, because maybe there is something specific. There is... okay, so this is PID, but this is a package. I'm trying to avoid using packages in Go because the infrastructure for compiling the Go part of caxa is just get a Go compiler and run Go build. And if you have dependencies, then you need to fetch those dependencies, and then you need to say like Go module install something or whatever. So it's not that hard to do, but it's complicated to do that in maybe the ARM architectures and emulated via Docker, and everything would be slower, and I don't want to do that. So here we are. And we don't really need PID files. I don't know exactly. I don't really care. I will just use some naive naming scheme, and I think it will be good enough. So log file, logged file, creates and manipulates files whose contents should change atomically. That's not the case. Proposal, get an exclusive lock on a file in Go. Okay, there is a fast lock. I don't want to do any of this because there is no concurrency of trying to write to this file at the same time. That's what an exclusive lock for a file would be useful for. If I had multiple instances trying to write or read to the same file, then I would need some sort of lock on that level, but that's not the case. So I don't need any of this. I guess we can just fall back to Go by example, writing files. I don't actually need to write anything to the file, but maybe writing to the file would be the easiest way of doing this. So I guess I will do that. And now IO util is not here. What are some other ways of creating a file? I can do everything by hand. That's not the way I want to do it. So maybe IO util will be the way to go. To start, here's how to dump a string or just bytes into a file. That makes me happy. So can I use IO util? If I save the file, then the Visual Studio Code extension for Go will put IO util at my import section, and I believe this comes with the standard library, so I don't have to install any extra packages, satisfying my need to run Go without extensions. So let's go to golang IO util, and yes, it is part of the standard library. So now I can say the name of the file, the thing I want to write, which will be an empty string. D1 is an array of bytes. Okay, let's go back to the documentation real quick. And what I'm using is write file. So write file. Write file writes data to a file named by blah, and it takes a slice of bytes. So I guess I will have to write something like this. And I actually don't need anything in the contents of the file. And the mode of the file, mode 644 stands for read, write for myself, and then read for everyone else, which I think is a fine way of doing this. So let's try this. And let's look at the modes for TMP modes. So yes, this is 644. So I'm happy just leaving this at 644. And then I need the path. So the path here is our app directory. Oh, not really. Here's how I want to build this path. I want to have something like this, except that instead of /runs, it will be /locks. Yeah, I'm happy with this. So /locks, and then the identifier. Start with the simple thing. Oh, it seems like the stream is having issues. So maybe you lost something of what I said in the last minute. Let me know in the chat if you missed something. So we will need a new name every time, and we'll need to run this in a loop, because remember, the last thing you do here is go back to step 1. So this will run in a loop. So we'll have to change this at some point, but I don't know exactly how we want to change this, so we'll leave it at that for now. So we'll have a folder with the locks, and then the identifier, and then this empty string and whatnot. So I think that this will create a lock file. I would like to test this in isolation, because I think there is already a wrinkle. I'm not sure that this locks directory will even be available to us. I don't know if it creates that directory for us. I don't think it does, but maybe it does. So let's write a simple Go program to test this out. This simple Go program will have a func main. And what I'm doing now is working around the problem that Go does not have REPL, as far as I can tell. I mean, there are some projects that try to give you a REPL, but they are not really a REPL, and they would be extra stuff for me to install and understand, so I never bothered. But because there is no REPL, I have to create a temporary file, and then I have to, write my sample program here. So the footer identifier will be something like awesome blah blah blah. So I'll copy and paste this here for this test. So with that, I can say go run source test.go. Okay, it succeeded. So let's look at our temporary directory. I guess the best way for me to do that is to have like a path named p, and then I'll do p, and then I will do format f print f, and then how do I print to the standard output in Go? Baby is going crazy. Okay, I have to say I'll wrap this up soon and go take care of baby. Print line, and then the string p. Okay. Save and go run that. Okay, it prints this, so that's where I need to go. I will open this directory. I'll open the caxa directory, and let's look at what we have there. So we have builds, examples, run, tests. This is all because I ran the tests previously on this stream. And then there is no logs folder. Isn't that weird? What's going on? There really isn't a logs folder. What the hell? Is it because I didn't put anything in the file? Or does Go just fail silently? Oh, Go fails silently. That's what Go does. Let's look at the docs. Write file returns an error, and I need to check for the error. Yuck. I wish it would just give me an exception. So and if is different from nil, then how do you say then? Do you not say then? How do you say and? Oh my god. Okay, it's brackets. So if then format, and what do I use? Log fatal f. Okay, that's what I'm gonna use. Log fatal f with Can I just do that? No, I have to pass it a format as well. So I have to say error and then /v, not slash, %v. Go run that. Okay, error, open blah blah blah, no such file or directory. Okay, so I remember that the untar has some sort of solution for this that will create the directories. So make dir all seems to be my guy. So here I will have to again check for errors. So I guess I will do this whole thing actually. And here I need to pass this p probably. And I save so that it imports the file path. And then I will have here a log fatal with my error. And creating a directory with 755, I think, is also the default. So if I make dir temp, I don't know, bananas, and check for tmp bananas, I want to check the permissions of the directory. That is a 7, that is 4, and that is 5, not 4. That is 755. Okay. So this does something. Let's go run source test. Too many arguments to return. Have error 10. What? Line 16. Too many arguments to return. Line 16, character 3. What the hell? I have no idea. Did I not save the latest version? Okay, that was the issue. I just have not saved the latest version. Okay, Felipe is saying, just wanted to let you know before I leave, GitHub Actions automatically published your beta release as the latest release. To release a beta, you need to say publish -- tag beta. Okay, thank you, Felipe. I actually noticed that because I tested it and it wasn't doing the right thing. So can I fix the error now that I already made the error? If beta version are something that will happen often, you need to run GitHub Actions accordingly depending on the value of the tag. Yeah, so this will not happen often because I don't expect that we'll have to play around with the build too often. At least not with the release part, not the publishing to NPM and publishing to GitHub releases. I don't think that will happen often, but it would be nice for me to be able to fix that so that latest points at 1.0. So if you know how to fix that, I would be happy to learn. Also, there is something else that I need to check that I forgot to check. So I'll open Visual Studio Code on my web application test again. I want to make sure that the checksums file is in there. So node modules, caxa, checksums.txt. So yeah, the post install will check for the checksums file. Because the file is there, it was released along with the npm package, and that's how we tie the trust between running on GitHub Actions and actually downloading the stub later. And Felipe says, I am not sure if you can change the tag of a release. Haven't had to do that. I don't know how to do it. I don't know either. It will be only in this bad state for a weekend at most, so I don't know. Maybe we can change that real quick. I'll try to do it. If I can do it in like 10 minutes, then I'll do it. And if I can't, then it will be in that bad state for a weekend. So the problem here is that the current tags, the latest is pointing at this version. So npm point latest at specific version. npm dist tag add package blah blah version tag. Okay, so I suppose I should be able to dist tag add caxa at 1.0.0. That's the latest, right? Yes, 1.0.0 should be our latest. Does that work? Let's see. I don't really think that I need to be in the caxa directory, but I want to make sure that I don't necessarily publish the web application accidentally, so I'll go back into the caxa directory. And I suppose I will have to log in unauthorized. Okay, so here's what I'm going to do. I'm going to switch so that you don't see me typing, and I will npm logging. And here I'll put my username. Is that my username? I forget. I think that's my username. What is my password? Hang on. Okay, I got my username right. Going to the... I was going to my password manager. And this is probably the email that I registered. Okay, I logged in. So now I can switch back to this camera. And with that, let's try to run dist tag. Latest points at 1.0, so let's refresh this. Versions, latest points at... Okay, so maybe it's just taking a while before it updates this. Whatever. Yeah, so probably fixed it. Thanks, Felipe. The thing that helped me here was to learn that it was because the latest was pointing at the beta, and that's what was tripping me. So yeah, probably the latest will point at the right one at some point. I'll leave this tab open so we can check this before we sign out for the day. Okay, so closing a bunch of tabs that I don't think I need anymore. Let's go back to our Go program that we were writing. So here we are writing this test that it will create a directory and blah, blah, blah. I want to open the temporary directory again. And really what I want to do is just get rid of everything in there. A clean slate. And then go run my source test go. And what do I end up with? A directory called logs, in which I find a directory called awesome, and then a file with the name of my project. Is that what I want? I suppose it is exactly what I want. Because yes, that is the path that I would like to create. Exactly, awesome. So now I have my test going and it does the right thing, so I can just copy what I learned into the main program. So let's see. Over here, I had my step 1.1.1. And I guess I will start by copying and pasting the whole thing, and then we have more space to work. So the path here, I'm calling it the path P. That's an unfortunate name. I should be more descriptive. Oh, that's so sad. I cannot use the rename refactoring in Visual Studio Code. It doesn't work. So I have to rename P here by hand. So I have to rename P here, and there, and there, and there as well. What is the name of this? It's the lock. And do I call it a lock file because the other thing was called an app directory? I suppose I call it a lock file, yes. So I'll call it a lock file. I don't need to print. I will need some of these lines. So path, join, temp directory, caxa locks, footer identifier. That's the part that I need to grab from here. And then I can delete everything from there, because everything else I already have over here. I don't need that actual content on the file. And here I have to check for errors. So I guess I will do make dir all path finder of the lock file. And if the error is different from nil, error. And here we'll say caxa stub failed to create a lock file. And then we will create the lock file. And I will do everything in one line the same way that I'm doing here. So I will do this. So merge dir, create the directory, then create a file with the lock file name and then nothing in it, and then this mode, and then check for errors, and then I will say caxa stub failed to create lock file. So failed to create the directory for the lock file, and here I will say failed to create the lock file. I think we did it. We created the lock file. In the last 10 minutes, let's look at this and refresh. And now latest points at 2.0.0 beta. So that doesn't work. So maybe the dist thing didn't work at all. At least it didn't create a new version. So okay, there is that. Okay, so let's go to step 1.1.3, which is to remove the lock file. So let's remove a file. How to delete a file? So golang delete file. How to delete or remove a file in Golang? Func remove, os remove, fine by me, os remove, lock file. Okay, I want to test this in context. I tested using that test program, and that worked. So maybe I can do a test here as well for the remove part, but I would like to test this in context, and for that I need to compile a new stub and create a new temporary project, but I only have 10 minutes left before I have to wrap up, so I will only do the test part. So os remove lock file, where the lock file here is called p whatever. And okay, so I'll comment out this part, and I'll come here to the temporary directory, and I will remove everything, and I will rerun my test to see it creating a directory, creating a file. And it did. It created a file. There is the file. Now I am going to do the opposite. I'm going to comment out the part that creates the file and uncomment the part that removes the file. and I will run again, and then I should see this file disappearing, and it does disappear. And I will leave this directory structure there. I don't care about it. I'll just leave the directory structure in place. So in context, this should work, but we will need to test it. I don't feel like testing this right now. It will be too much work. And then we have to check that we have to look for the log file, so you'll have to do a lot of handstanding to get the file info and whatnot. That will be long as well. And then there is also the issue of having to do a loop around this whole block, because we need to extract the thing to the right place. So there is a whole lot of things that we have to do here. We have to do the loop, we have to do this part, and all of these things that we have on the table are kind of long. So I guess it's time for us to wrap this up. I'm going to commit what we have. So here we have a test file. We don't need that. And then we have the stub file. Let's read over what we have. We have a bunch of comments. We have those new lines, and that's good. So I am committing this and pushing. And with that, we will wrap this up. On Monday at 5:30 UTC. Here, baby, I have to go back to that. Baby is calling for me. So yeah, starting Monday, we will test the thing in context and see if the log file is created and see if the log file is removed. And then we will write the code to look at the log file and create new names, and we will do a loop, and then we will have solved this. And after that, there is only the problem of adding command line parameters to customize the preparation of the application, which should be relatively straightforward. It should not take too much time, especially because it's in JavaScript, and I know JavaScript better than I know Go. So yeah, that's what we have on the plate for Monday, 5:30 UTC. I see you there. Thanks for watching. Thank you, Felipe and Lauren, for being here today, and everyone else who was here and did not comment anything on the chat. Make sure you support me on Patreon and PayPal and subscribe to the channel. I'm hitting almost 500 subscribers, which is exciting for me. So yeah, I see you Monday. Have a good weekend. Bye.